Alright, and welcome to the third part, which is going to be the section that kind of ends off part one of our Intro to Kinematics unit. So we start to talk about graphing uniform motion. And for this activity, when you're ready, you come on up. I have a little Pascal Match Graph application that we can use. And for the video's purpose, I'm just going to kind of discuss what the graph would give you and what it looks like. But I do encourage that you come up and try it out. It is a lot of fun just to kind of see what it looks like. So for the match graph, I've got an example line here that's drawn, and we can see that we have position on our left going in the y-axis, and on our x-axis we have time in seconds. And so we have a line that's moving up, and that line would kind of indicate that position is changing as time is moving on. So basically we have a distance and we have a time. And so we can start to answer some kind of general questions about graphing and what this looks like. So some things that we can take away from this graph from what we just saw. What variable is on our x-axis? Well, our x-axis showed our time variable, and it was measured in seconds in that case. What variable's on the y-axis? Well, our y-axis showed our position or our distance. And then what do you think the slope represents? And so this one is a little bit different. The slope of our line, remember from before, slope just represents our change in our y-axis to our x-axis. So our slope takes different segments of the line and just compares how far did it change from point A to point B. So if you compare this, it's really how far did it rise to how far did it run, right? How much position changed per how much time. Or another way to think about it would be how much position changed per how much time, right? D over T. Now we have an equation for this. So our slope of our line actually represents our speed. And so what's happening when the slope is flat? Well, in this case, if we have a flat slope, that means that time is still passing by, but you're not gaining any distance. So your speed would be nothing. It would be zero. You're not moving. If it's increasing, that must mean that you're moving forward in your distance. And if it's decreasing, if your slope is kind of showing a bit less of a slope, right? It's not necessarily going down, it's just showing a smaller slope value, it's decreasing. That means that you're not covering as much distance as time is still moving on. Right? More distance and less time, you'd have an increasing slope, and then a little bit less distance as time passes by, your slope would be decreasing. And then when can we get this negative displacement value? So how can I actually end up in the negative area, as this shows down here, right? Negative below zero. So I can actually go into a negative displacement. You'd actually just have to go negative distance, right? Which starts to connect back to what we talked about when we talk about south or west. All right, so plotting uniform motion. You will need a little bit of graph paper for this. And so what I would encourage you to do, examining the following table, is to start to plot some of these out. Okay, so what is the average velocity for this event? So if you were to just look at the table that's here, what would you say the velocity of that is? And so we know that velocity or speed, in this case, is our distance over our time, displacement over time. So we take 12 and divide it by 1, we'd get 12, or we take 24 and divide it by 2, you get 12, 36 divided by 3, you get 12. So it looks like the speed is staying pretty consistent at 12. And so it's saying, what do you notice about the distances as the time increases? Well, in each one, each increment going here, it looks like it's just going plus 12 every time, right? As the pattern tends to continue the whole way down. So what happens with our time value? Well, our time value keeps increasing by 1 every time. So that's why we have distance over time. It's 12 divided by 1. Okay, so what do you notice about that? it's the same. Okay, it's uniform. It's moving at an expected increase each time. Okay, it's not a surprise that you couldn't keep predicting the rest of this table. So, what does our event look like graphed out? Take a second with a piece of graph paper